I'm Luke, and in this diagnostic training module, we'll be covering oxygen sensor poor performance. Specifically, we'll be focusing on zirconia narrowband oxygen sensors and the techniques and equipment we can use to help us diagnose poor performance. Oxygen sensor poor performance is often overlooked by technicians, as DTC codes for poor performance normally don't illuminate the check engine light. This is another example of why you should check every vehicle for DTCs, even if there is no check engine light. In this training module, we'll be testing at the component itself. Keep in mind, however, that it is imperative that you carry out testing at the appropriate pin location on the control unit. We begin our testing by visually and physically checking for damage before moving on to electrical testing using the multimeter, a scan tool, and finally a lab scope. There are over 30 different codes relating to poor performance. Regardless of the fault code you have, always start by physically checking the sensor itself. For example, I have an old oxygen sensor here. So what we're going to do is actually pull back the insulation on the oxygen sensor. Don't be afraid to do this because you want to actually check the actual wiring on the sensor itself for any broken, chafed or burnt wires. Make sure you check both ends. It's very important because sometimes you can miss it. Another thing you can check is oil contamination or any dirt or anything around the top of the sensor here which will actually interfere with the performance of it. And finally, check the actual plug connector on the end. So for any burnt out contacts, corrosion or any pushback pins that may cause interference with the sensor itself. So now that we know the sensor's okay, we need to move on and check our bias voltage at the ECU side on the oxygen sensor plug. So let's go do that now. So I'll just grab my multimeter and we'll actually set it to volts, DC. I'll just pop this in my manifold. So I'm just going to go down here and disconnect my O2 sensor. So you're actually testing the ECU side. So we're going to check our bias voltage, which is pretty much our reference voltage coming out of the ECU. So I'll just go around and turn my ignition on. Just to wake the system up. Now what I'm going to do is I'm going to check the signal line and the ground at the pin connector. So I've disconnected the O2 sensor, remember? And I'll just pop it in here, grab the plug. So we're looking for around 450 millivolts. So we've got 436 millivolts, which is great. There's nothing wrong with that circuit. So we've just confirmed that the circuit's okay. So we know we've got no broken wires, no chafed wires, and definitely no power problems. An important note, never test an O2 sensor using ohms reading on the multimeter itself because the current coming out of the multimeter can actually damage the sensor internally. So the next step is to actually connect the scan tool to the car. And in this case, this scan tool is wireless. So what we're going to do is actually look at the live data read by the ECU. We're going to look at the oxygen sensor. So what we'll do is, we're in graphing mode, and I'll just increase that to make it bigger. So what we're going to do is, I'll get my assistant to start the car. On the left here we have our voltage, and on the bottom we have our time scale. Now at the moment, the car's in open loop. So once we wait for the sensor to warm up and the system to go into closed loop, we'll start to take some readings. So I'll just get the car to rev up to 2000 RPM. And here you can see the sensor starting to work. So here you can see now the sensor's actually reading, but unfortunately the sensor's not actually reaching its peak voltage as seen here. And it's the pattern's actually very irregular, and unfortunately the time scale isn't very meaningful. So to actually read this properly, we actually need to connect this up to an oscilloscope and actually look at the signal waveform on the actual oxygen sensor. So let's do that now. Now that we've got our picoscope connected up to the oxygen sensor signal line, let's play the picoscope, start recording, and I'll start the car and we'll get some readings. So I'll just let that warm up for a minute. And once it starts reading, I'm going to hold the car up to 2000 RPM. Okay, so we're starting to read now. So I'll hold the revs up. So I'll just go over here and pause this. I'll just quickly switch the car off. So I've carried out the test again using an oscilloscope, and I've actually recorded the data. So let's take a look at what's happened. So as you can see here, it started at around 120 millivolts and it's climbed. So this area here is actually okay going up to the rich area. And as you can see here, coming back down into the lean area here, it's actually quite slow to respond, but it's actually shot up again into the rich area. Now, the difference is, compared to the scan tool, is we actually see the detail of the cross counts now. Unfortunately, the scan tool's data is too inconclusive, and it's hard to tell whether the oxygen sensor is slow to respond or the sample rate is too low. So, usually a good signal waveform on an oxygen sensor will be 15 cross counts every 10 seconds. And in this case, the cross count here, it's only doing one every second. So that just concludes that the oxygen sensor is faulty and we need to replace it. So let's do that now. So now that I've replaced my oxygen sensor with a new one, I've actually carried out the test again using the oscilloscope, and I've actually saved my live data. So let's take a look at what's actually happened now. So as you can see, it's actually risen and fallen as quick as each other across the range. And our voltage is very adequate across the top of the screen here. And actually our cross counts are nearly identical across the entire screen. So this is actually what a good oxygen sensor waveform should look like, and it's conclusive evidence that the old oxygen sensor was faulty. This concludes our diagnostic training module covering oxygen sensor poor performance. Always remember to replace oxygen sensors in sets, as it keeps the readings consistent for the engine control unit. And also, equipment will also have its limitations. That's why it's always best to use an oscilloscope, as we used before, to check these components. I hope you've enjoyed it. Thanks for watching, and bye for now.